In last week's video, I showed you the differences between the physics system included by default in Godot, Godot Physics, and Jolt, a third-party library that can be integrated into your game using the Godot Jolt plugin. In that video, I demonstrated how Jolt could achieve up to 131% more performance in terms of physics management within Godot. The response to that video was overwhelming. You wrote me a lot of comments making your observations, and even with your suggestions on what else could be tested. And about this, I want to say to you that thank you. Thank you for giving me all those suggestions because they have inspired me to carry out a new battery of tests that I bring you in today's video. What is this mysterious option of moving the physics computation to a separate thread? Does it help to separate the objects which can collide with each other to improve performance? And what will happen with the same performance test if we created the cubes directly from the physics server instead of instantiating nodes? Well, in this video I intend to answer all these questions. If you have not yet seen the previous video, I recommend that you watch it before this one, since this is a natural evolution of the test I performed in that other video. This week I have deepened my knowledge of Godot, and I hope to be able to transfer all that knowledge to you through this video. So, stay with me until the end so we can learn more about physics in the Godot game engine. One of the comments I received was from this user, who states that Jolt is capable of optimizing the scene even further if the physical objects are separated. In order to test it, what I did was create copies of the initial benchmark where there was a separation between each copy. In this test, I have multiplied the cube creation time interval by 3 in order to have the same number of cubes created per second as in the previous benchmark. Before seeing the result of this simple test, let's review the results of the benchmark in the previous video. With Godot Physics, I got 42 FPS on my laptop and with Jolt 97, which represents an increase of 131% in terms of performance. In this test, in which I created 2 more copies of the test and separated them, I obtained 43 FPS with Godot Physics and 81 FPS with Jolt. In this case, Jolt has performed 88% better than Godot Physics. But the expected result of Jolt performing even better has not only not occurred, but has performed below the previous level. To tell the truth, this test is done a bit in the air, without really understanding if this feature exists or if something else needs to be done to activate it. In any case, I repeated this test, but this time distancing each copy twice as far as before. The result is 41 FPS with Godot Physics and 81% with Jolt, giving a total of 97% improvement. As I say, I'm not saying that this feature doesn't exist. In fact, it seems like a very plausible way to increase the performance of a physics engine. What may be happening is that it may not be active in this version of the plugin, or perhaps some additional configuration needs to be done for it to take effect. In any case, if anyone knows anything more about this feature and how to activate it, let me know and I will try it. One of the doubts that arose in the previous video was this check that we found in the 3D physics section of the project and that allows us to move the physics calculation to a separate thread. Many of you told me that maybe what it is for is not when you only have physical objects colliding, but when you also have scripts with logic that are eating up machine resources. The hypothesis here will be that since the main thread is busy performing the operations of those logic scripts, if it also has to compute the physics calculations, we are losing performance. So if we move that computation to another thread, we could improve the performance of the game. In order to check whether this thesis is true or not, I have added a node to the test scenario that does precisely that. This script is continually multiplying matrices, an operation that, depending on how large the matrices are, can be quite demanding on the CPU. As soon as we run the test, we can see that the initial frame rate is already much lower than in the previous test. This is undoubtedly due to the fact that this node that multiplies matrices is taking up part of the machine's resources. From here, what I have done is run the same test as before. First 3 times without having the option to move physics to a separate thread activated, and then 3 times with that option activated. Same methodology as always. The result of this benchmark with the option to move physics to another thread disabled has been 18 FPS for Godot physics and 20 FPS for Jolt. In this case, Jolt has only increased the performance of Godot physics by 11%. And now let's see the result of activating the option to move physics to a separate thread. 18 FPS for Godot physics and 20 FPS for Jolt. Again, an 11% improvement. That is, as this project is configured, the option of moving physics to a separate thread has made absolutely no difference in performance. However, despite seeing this, I did not give up. I thought that maybe I could try to stress the program in another way, so it occurred to me to stress the rendering process, which in principle runs on the GPU, just like the physics one. To do this, I looked for a fairly detailed 3-dimensional model and put it around the cubes to see if it had any effect or not. And again, in this case, there were no significant differences. After all these tests, I asked on the Godot forums about this question, and basically the answer was that the advantage is the mere fact of moving the physics to another thread. It is possible that in a large and complex project where you have to be careful with which thread manages what, this could be something significant. But I think that in this very simple benchmark that I have created, it is not the ideal case to check it. And now let's move on to the last test of all, which is something that several of you were asking. Creating the cubes through the physics server and not through the node system. For those who do not know what exactly the physics server is, here you have a very quick explanation. Each of the elements of Godot, physics, rendered elements, sounds, are managed by so-called servers. When you create a game composed of nodes, these nodes in turn use these servers. The node system has been created to facilitate the development of video games. However, if you bypass these nodes and run the calls directly against the servers, the performance should be better since you are skipping an intermediate layer. If you are interested in this topic, let me know in the comments and I will make a more detailed video explaining it better. This time the test is quite simple. I have created a different script where instead of creating each cube as a node, I do it at a low level using physics server and rendering server. Let's see the results. For Godot physics, the result was 84 FPS and for Jolt 96 FPS. In this case, it seems that using the servers has served to increase performance, especially when Godot physics is in use, and it does not seem to affect Jolt for some reason. Godot physics has improved its performance by 14% and Jolt has remained practically the same. Without a doubt, a curious result, but in any case, Jolt continues to lead the way in terms of performance. However, if for whatever reason you still have to use Godot physics and are looking for a way to improve its performance, I recommend that you try not using nodes and make calls to the server's API instead. However, I warn you that it is a very low-level API and that doing things there is much more complex than working with nodes. This week I have learned a little more about Godot and I hope you have too. If that is the case, please leave me a like to help me grow this channel and subscribe to see more videos like this. Thank you for watching this video until the end. I hope you have a beautiful rest of your day. Goodbye.